Stream at starting. Hello guys, welcome to the stream. We'll get into the discussions of today's contest of Leetcode starters 433. Sorry, weekly contest 434. I welcome you all for today's stream. So guys, did anyone view today's contest? It was a good contest today. Like even the LLMs failed. There were very less GPT coders comparatively. After a very long time, Leetcode contest seemed very genuine today. So we'll go to our first question. Today's first question was count partitions with even some difference. This was today's first question. So for this question, you are given with an integer array nums of length n. So there's an integer array given of length n. A partition is defined as an index I where I is greater than or equal to 0 and lesser than n minus 1, splitting the array into two non-empty subarrays such that left subarray contains indices 0, I and right subarray contains indices I plus 1, n minus 1. So we have to return the number of partitions where the difference between sum of left and right subarrays is even. So for example, they have given an array here, nums 10, 10, 3, 7, 6. So now, if we do a partition, it has four partitions they have said. We'll see how. If we do a partition here, if we split it at 10 one side and 10, 3, 7, 6 one side, the sum of difference is 10 minus 26 minus 16, which is even. Next, if we split after 10 comma 10, then also it will be 20 minus 16. It is 4. Next, it will be 23 minus 13, which is 10, which is also even. And 10 comma 10 comma 3 comma 7. And then if we split it after 6, like after 7 with 6 separate, then again it is a even sum. 30 minus 6, which is equal to 24. Again, 24 is an even number. And if we go for 1 comma 2 comma 2, however we split it, we'll never get any, like it's not possible to partition the results and get the even sum difference actually. So now what are the constraints of this question? The constraints are nums dot length and n should be equal and it should be lesser than 100 and greater than 2. And nums of I index should be less than 100 and greater than 1. Now, what is the approach we can use to solve this question? Anyone in the chat? How can we solve this question? How can this question be solved? So, to solve this question, the intuition is we have to find the partitions so that left subarray and right subarray difference is even. Simple one. And what we'll do here for this? Difference between two sums mean if it's even means the total sum of array should have same what you say same. It should be odd or even. It if one is odd and the other one is even, it's not possible to have a even sum. Now, what approach we are gonna use for this? Sorry. So the approach we are gonna use for it is first we have to calculate the prefix sum. To compute prefix sum, we'll make an array and we'll accumulate the values to the array prefix sum. And then this prefix sum array, it will help us to calculate the sum of left subarray at any partition. It will directly calculate our difference at any given this one. And then for every partition index, if it is total sum minus 2 divided by left sum is even, this condition we can simplify it. We'll use bitwise operations here. And finally, what we are going to do is count the number of valid partitions. In the end, we'll be counting the number of valid partitions. Now, the key steps here, first one is prefix sum array, prefix minus 1 and prefix I, total sum of the array and sum of left sub array. And next, even difference should be checked. And then we have to count the valid partitions using sum. So we'll go to the question. Sorry, we'll go to the code of this. So the code of this is gonna be like this. Class solution which is given. Then define count partitions function which is also given self comma nums list integer output integer prefix is equal to. So okay, now this is prefix sum array calculation. Prefix sum computation with initial value is equal to 0. Why are we taking initial value is equal to 0 here? There's not. It's just to simplify the calculations for the further steps. Now this will store the prefix sum values here, and the next one here. After this, we'll make it step 2. What is our step 2? I said we have to count the partitions. Count the partition We have to count the partitions where sum is even. So it's where the sum difference is even. What the condition is gonna check here? If what will this check? Total sum minus 2 into left sum. Total sum minus 2 into left sum is even. This condition is checked here. So now this is the code for I in range 1 comma length of nums. This is an array which we are using here. Now we'll run this code. It is accepted in the shown test cases, trial test cases. Now we'll submit this one. So it's accepted here. We'll see the time complexity. Anyone in the chat, what is its time complexity? What is the time complexity of this one? So for prefix sum calculation, it's an array we are using. It will be O of n. Again, iterating of this over the same array. It's gonna be same O of n. And finally, the answer, like the time complexity of this is gonna be O of n. And what about the space complexity? What about the space complexity? Anyone in the chat? What about the space complexity of this question? The space complexity of this is also gonna be O of n. So anyone has any doubts in this first question? The time complexity and space complexity both are O of n here. So chat, anyone has any doubts? If there are no doubts, we'll move on to the next question, chat. Okay, we'll go to the next question. The next question is count mentions per user. So we'll read this question first. Count mentions per user. You are given with an integer number of users representing the total number of users and an array events of size n into 3. So there's an integer number of users and total number of uh, integers is total number of users is represented by number of users, and there is an array called events of size n into 3. Every event I can be either of the following types. 1. Message event. Message, comma, timestamp, comma, mentions string. This event indicates that a set of users was mentioned in a message at timestamp I. The mention string can the mention string can contain one of the following tokens. ID number, where number is an integer in range 0, comma, number of users minus 1. There can be multiple IDs separated by a single white space and contain duplicates. This can mention even the offline users. Mentions all users. All. This all is gonna mention all the users. And then here is gonna mention all the online users. This is similar to Discord, how Discord works. If we tag everyone, everyone in the server will be tagged. If we tag here, everyone who is active in the server currently, who are online, they will be tagged, and the offline user, like the users who are offline, they won't be tagged. Similar to that, only here it's all and here. Going to the second type of events, which is offline event. Offline event will have this three categories in it, three things in it: offline, timestamp, and ID. The ID is the user ID. The event indicates that the user ID had become at offline at timestamp I for 60 time units. The user will automatically be online again at timestamp plus 60. For example, he went offline at 9:45. He'll again come back online at 10:15. 60 time units. They have not mentioned anything. It might be 60 seconds, 60 minutes, or anything. It's just 60 time units. So timestamp, if I leave at this point, what is the time now? The time is 10:05. If I leave at 10:05, I will come back after 60 time units. So what they're asking us to do is return an array mentions where mentions of I represents the number of mentions the user with ID I has across all message events. All users are initially online, and if a user goes offline or comes back online, their status changes processed before handling any message event that occurs at the same timestamp. Note that a user can be mentioned multiple times in a single message event, and each mention should be separately counted. This is basically a question which they have given as medium tag, but it's actually having a lot of complexities within it. First, we have to count where there are a lot of things to be calculated here. For example, when the user is gonna be back online, and how many times he is tagged, how many events he attended, and in every event, for in one single event, he can be mentioned 10 times or 20 times also. So yeah, every count in every mention should be counted separately. We'll go for an example here. Input is number of users, which is 2, and the events message, comma 10, message, comma 10, ID 1, ID 0. Now, offline 11, 0. Message 71 here. So, this says that at timestamp 10, both ID 1 and ID 0 are mentioned. This thing, ID 1 and ID 0 are mentioned here. This is the thing. And at timestamp 11, ID 0 is going offline here. As I said earlier, offline comma timestamp comma ID. ID 0 is going offline at 11 and his status is offline. Next, at timestamp 71, so 11 plus 60 time units. So at timestamp of 71, the user with ID 0 is back online. So when the message is there here, the status of him changed here from offline. This offline changes to here, which means he's online, he's back online. Now, so we got into the example. Now we'll see the constraints for this. Constraint, number of users is always less than 100 and greater than 1. Obviously, if it's 0 users, then the final answer is 0 itself. And events length should be greater than 1 and lesser than 100. If there's no events, there's no one who is mentioned. So yeah, there should be at least one event and the maximum event should be 100. Events I dot length is equal to 3. Next, events I comma 0 or events I and 0 will be one of message or offline. It can be either message or it can be offline. So what is the condition for events? Integer events I1 is always lesser than 10 power 5 and always greater than 1. The number of ID number mentions in any message is between 1 and 100 because the number of users is maximum 100. So ID mentions is less than 100 here. And then number is less than number of users minus 1. So and also it is guaranteed that the user ID referenced in the offline event is online at the time when the event occurs. They have given these many conditions here. Okay, we'll see the hints. Sort events by timestamp and then process each event. And what is the hint to? Maintain two sets of offline and online user IDs. Okay, now we'll see. We'll first go to the intuition how this question can be solved. What is the intuition for this? Anyone in the chat? Any method how we can solve this question? How this question can be solved? Any idea? Anyone? Any idea how this can be started? So what is the intuition? Intuition is this problem. Actually, what was in the hints is the exact same intuition for this. It keeps track of mentions for each user based on specific events while managing online and offline status of users. Our goal is to keep count of all the mentions. The main challenge here is we have to process the events in chronological order and also we have to handle online or offline status at the same time simultaneously and also we have to ensure that mentions are updated successfully. So that's why I said this is a bit complicated question to be given for second question. So we'll see the approach we are gonna use. First one, the first step will be sorting the events. We'll sort the events by their timestamp in ascending order. So if we sort it, if there are two events having same timestamp, for example, at 11 time units, there can be an event offline and also there can be an event message. Then we'll prioritize offline before message. So this is our first step in the approach. Next, we'll go to the second step. Here we'll initialize it. What all? We'll use an array result RES to track the number of mentions for each user. And then in the second step, the second thing we are gonna do is we'll use an array online to track when each user is online, and also online of I will represent the earliest timestamp after which user I is online. So this will be our step 2. In the step 3, what we are gonna do? Process events. For each event, if event is a message, so we it's a bit important here. Processing the events, which is actually the major part of this question. Until now, whatever it was is basically sorting and storing, so it's easy. Here is the actual logic of this question. Processing the events. For each event, if the event is a message, if it's a message, if there, again, here comes three conditions. If message mentions all users, we have to increment the message mentions for all users, irrespective of the irrespective of the people or the users are online or offline. We have to add one mention to everyone. If the message mentions that here, here means only online users, then we have to add time only for the people who are online. So, and the next condition, if for example I mention ID is equal to 01, in that case, only the person at ID is equal to 01 should be mentioned, should be counted. Only his mention should be counted. So, there are three conditions when the event is a message. First condition is if all the the message mentions all, then increment should be done for all users, irrespective of offline or online. And going to the next thing, if it mentions here, then the users who are online, only the users who are online, only online users should be counted mentions. And then the final one, if it's mentioning a specific ID, for example, ID is equal to 02 or 10, then only the person with ID 10 and 20 and 02, only those two should get one mention added to their IDs. So now, after this, there's one more thing here. What? If the event is offline, if the event is offline means the user is offline basically. What we have to do? We have to add a timestamp of 60. So, for example, it's 10:15, 60 time units. It can be 60 time units. Here will take us 60 minutes. So, if 10:15 is offline, then the current timestamp will be next online timestamp will be 10:15 plus this 60. So, what this will be? 11:15 basically. If we consider 60 time units as 60 minutes. So this is the most important, processing the events. Next is finaling the mentions. We have to finalize the mentions. We have to add all the mentions for all the messages for all the users here. And then finally we have to return the results. Result is a result array representing total mentions for each user. We have to just return the total amount of mentions for every user. Now, we'll remember the key points here. First thing, sorting the events should be in chronological order. Which event happens first should be first, next should be next. We should keep in mind that this happens perfectly and there won't be any mistake here. And going on to the second thing, all and here messages should be handled differently. Because one place we are including offline users, in the other places they are excluded. When it's all, offline users are included. When it's here, offline users are excluded. Now, going on to the third step. Third step is online array. This online array, we have to keep the track of this to keep count of users who are available for here messages. For example, there are 20 users and 10 of them are online. So when the command here is used, then the number of mentions will be for this 10 people, and then every user will get one mention. So the total number of mentions per person is one, and overall 10 people are mentioned. So it's very important to keep a track of users' availability. This question, now we'll go to solving this question. Okay, so class solution which is given, and then define count mentions which is also given. The function name and output is an integer array. Now, going on to the first one, as I said, we have to sort it. We have to sort the given events, and this happens in this step where before this events, the first step, sort the events in sort the events in chronological order, and it should prioritize it should prioritize offline events first. Highest priority is given to offline. Remember, we are using an array, not a priority queue, so there won't be any change. We'll be prioritizing first the offline thing. Going on to the next one, we'll print the events here. Next, result. This is initializing results. Initializing initializing results and online status. In the next two steps, we are just initializing results and online status checkers. This online O of 0 into, sorry, index 0 into n. And then this tracks online users, tracks going on to the next question. The next one, all count. It counts all the mentions from messages, whichever will have all. If it has all, if the message has all, it will count it here. So the initializing part is done. Now we'll go to the next one. The TY stands for event type, TS stands for timestamp, and S stands for data. So what are each? I'll just write it here. Where shall I add it? Yep, here I'll add it. Hashtag TY stands for type of event. Hashtag, no need of hashtag. TS stands for timestamp. S stands for data. So now the first for loop. for events, comma timestamp, comma data in events. What is this? For event type, comma timestamp, comma data in events. First step, if type of event is equal to message, what we'll do? And then we'll check one more condition. If data given is equal to all, then what we have to do? We have to increment for all online users as well as offline users. All means for online and offline. So all count plus is equal to 1. We'll increment 1 for all count. Everyone's count will be incremented with 1. Now, else if s is equal to data, which is data, s is data. If it is equal to here, then only online users should be mentioned. So what we'll do here, we'll run another for loop, which will go this way. For I in range of n, if online of I is smaller than integer timestamp, then we have to add for result, we have to add 1. We have to increment for all online users. Increment for all online users. Else, the last condition, where if someone is mentioned, for example, there is a guy named X, and that X is actually mentioned here. XID will keep it as X01. X01 is mentioned here. So what we should do is we have to count only S01, X01 now. So now for what we'll do? This else case is for specific users first. Hashtag specific users. Now mention IDs dot split. We'll split it to extract user ID. Now what we'll do for ID in range mentioned IDs, for ID in the range mentioned IDs, we'll count it and we'll store it. It will count specific. So specific user is incremented here. Else, when the event type is offline, basically there are only two types, so we'll directly use else. Then update online timestamp. Update online timestamp. So this is done now. And finally, the mention for all users. To add mention for all, add mentions from all. For this, we'll use this array. From all messages to all users. To all users, we'll use this. And finally, we'll return the result. This is the result array. Now we'll run the sample test cases and we'll see if this runs. So it follows the sample test case. The output is 2 cross 2 comma 2 array, and expected is also 2 comma 2 array. Now we are going to submit this question. So this question is accepted here. Now, what is gonna be its time complexity? Anyone in the chat, what is gonna be its time complexity? I'll show you the code. So here is the code. What is its time complexity? We are using dot sort, events dot sort, array dot sort basically. So I have told what the time complexity of array dot sort is. It uses tim sort, and for sorting it takes O of n log n here. So what is gonna be the overall time complexity of this? Anyone in the chat? What can be the overall time complexity for this? The time complexity of this, the actual time complexity of this is gonna be O of n log n for sorting, and then for processing the events, O of n, and then for events offline, O of 1, and finally for total processing, it will take O of small n into capital N, and in the given test cases, the total time complexity will be O of n log n plus small n into capital N. When we apply the given constraints and get only the dominant terms, the final time complexity of this is gonna be O of n log n. And what about the space complexity? First, input storage, for which O of n into k we are using, and for output storage O of n. Now the space complexity will be O of n into k plus n, and like O of small n into k plus n. Here k is given as 3, so we can ignore it since it's not the dominant term. And considering the dominant term, this is gonna be O of capital N. So we'll go to the next. Any doubts in this question? Anyone in the chat? Any doubts for anyone in the chat, guys? Guys, we'll take a small break for 2 minutes. I'll be back for third and fourth question. Both the questions are lengthy, so I guess there are no doubts up in the first and the second questions. Hello guys, I'm back again. So we'll go to the third question. The third question, what is the third question? The third question is maximum frequency after subarray operation. So Maximum frequency after subarray operation. You are given with an array nums of length n and also an integer k. So they have given an array of length n and the name is nums and also an integer k. What we have to do? We have to perform the following operation on nums. Once, select a subarray nums I to j where I is lesser than j and j is lesser than or equal to n minus 1 and I is also greater than 0. And we have to select integers x and add that x. We have to select the integer x and add x to all elements in nums I to j, the array nums from I to j. So this is the first step. Then we have to find the maximum frequency of the value k after the operation. So after this, we have to find the maximum frequency. And every time they define subarray is a contiguous non-empty sequence of element within an array. This question seems very easy, but it's not that easy. It's a medium question as I have mentioned. It's not super hard at the same time, it's not super easy also. So we'll start solving this question. So here actually what we are doing is we are just finding the maximum frequency of k, that's all. What is gonna be the intuition for this question? Anyone in the chat, what is gonna be the intuition for the particular question given? What is gonna be the approach or what is gonna be the intuition to solve this given question? The intuition to solve this question is gonna be we have to find the maximum frequency of given value in the array after performing one operation, and then the operation always allows selecting a subarray and adding the constant to all elements. For example, we have to get a subarray and we'll consider constant 1. 1 is added to all the arrays. Maybe the next constant will be 2, then we have to add 2 to all. Then the constraints, what are the constraints? Sorry, I forgot to check the constraints. The constraints are nums length is less than 10 power 5 and it's greater than 1, and nums of I index value is less than 50 and case value is less than 50. So now, what is gonna, we'll just check one example so that it will be easy to understand the question. The array given is 1, comma 2, comma 3, comma 4, comma 5, comma 6. It's an array from 1 to 6 and k is equal to 1. So the output they have given is 2. After, we have to add minus 5 to it, nums 2 to 5. So 1 has frequency of 2 in 1, comma 2, comma minus 2, comma minus 1, comma 0, comma 1. So the output is gonna be 2. Now, because k is the thing, k is the value which we have got, and how many times k has occurred at index position 0 and index position 5. So the output is gonna be 2. Now, what is the approach we can use to solve this? Anyone in the chat, what approach can be used to solve this? First, we have to pre-compute the counts. For that, we have to use a counter and pre-compute the frequency of elements in the numbers. For example, here 1, 2, 3, 4, 5, 6. the frequency of all elements is 1. So first we have to pre-compute that. Then we have to initialize a default answer. For example, we have to start count of the array and the minimum frequency of f is this. For example, it's 0 or 1. Then we have to iterate over other numbers. We have to iterate over other numbers here. For each number present in the array, we have to determine the maximum contribution it can make for the frequency. For that, we have to consider subarrays which can be transformed into the numbers here. Which can with the subarrays which can be transformed into arrays or subarrays again. Now, after this, we have to use a very important and a very what do you say, the most commonly used approach, which is sliding window approach, to check the number of subarrays containing the number. And also here in the sliding window, we have to track two variables. What are the two variables? Score, and the second one is KS. Score is how many we can turn into, and KS is how many we already in the subarray. And then we have to adjust this window when transformation score becomes infeasible. Like when there are too many, decrease the score. So, and then finally we have to upgrade the maximum frequency. This is our final step. So our final step is gonna be updating the maximum frequency. For that, we have to combine the count of all the subarrays, and we have to combine the count of transform sliding window. So anyone in the chat, how can we solve this question? Which approach we can use to solve this question? I have said. Anyone? What else can be? Anyone? How else can we solve this? Anyone in the chat, guys? How can we solve this question? Okay, we'll go to the code directly. It's not that difficult code. It's a very simple code. First, we have to create a class, and then the given the what is a function which is already given, define max frequency, and next pre-computing. The first step, I said the pre-computing step, and after we pre-compute, step two. What is the step two, guys? We have to initialize the default, initialize the default. We have to initialize the default max answer. So the max answer is gonna be C of k, count of k. That is gonna be the max answer initially. For I in range 51, why we are taking 51 directly here? There is a thing that the max value of k is 50. So for I in range 51 means for I from 1 to 50 will be considered here. What is this? We can skip two things here. Which are the two things we are skipping here? We are skipping I is equal to k, or I is not in array. So that's why we are just taking to range of 50. Going on, we'll consider a if loop, if case. Here we'll initialize, after that, we are gonna initialize the variables for sliding window. Here, initialize, here we are gonna initialize the variables for the sliding window. Now, the next one. What is the next one? We'll go for another while loop here. So we'll create a while loop, and here in this while loop, this is for sliding window. This is our step 4. This is our sliding window. And the sliding window to calculate the score. Now, first if condition, if start is equal to I, we have to increment. Next, if nums of start sub equal to I, increment. Or else, now the next if else if condition or elif condition, it is very simple. If start sub is equal to k, we have to increment it again. And now, if ks, I told earlier what is ks. Ks is how many are already counted in the subarray. How many frequencies are already counted in the subarray. So for this, we'll use this k. And now, here finally, we'll restart if ks exceeds score. We'll restart the sliding window again. And finally, we are gonna update our answer. Update our answer. So, and finally, we are returning the answer ANS. So, we'll run this code and check if it runs for the sample cases. It's running perfectly for the sample cases. We'll submit this question. So, guys, this question is also solved. Anyone has any doubts in this question? Anyone in the chat, any doubts you have? So, what is gonna be its time complexity? Total time complexity. Outer loop runs for 50 and the inner loop sliding window loop runs for n times. So total time complexity is gonna be O of 50 into n. So 50 is a constant considering the dominant term. The time complexity is gonna be O of n. And what about the space complexity? The space complexity, anyone in the chat, what is the space complexity? The space complexity is also gonna be O of n because it is the space required to store the frequency of elements in the nums. So the final time complexity is gonna be O of n, as well as the space complexity is also gonna be O of n. So I guess the third question is clear. Anyone in the chat, do you have any doubts in the third question? If not, we'll go to the fourth question. So I guess we can go to our fourth and the final question. So chat, before going to the final question, do you have any other doubts? Any doubts, chat? Are there any doubts for anyone in the first three questions? If not, we'll go for the fourth and the final question and the most complicated questions. So we'll go to our final question of the day, chat. The final question, frequencies of shortest super sequences. This question you are given with array of words, array of strings words, and then we have to find all shortest common super sequences of words that are not permutations of each other. And what is the shortest common super sequence? It is a string of minimum length that contains each string in words as a subsequence. And for this, we have to return a 2D array of integers frequency, that is FREQs, that represent all the SCS. SCS is shortest common super sequences. Each FREQs of I is an array of size 26, representing the frequency of each letter in the lowercase English alphabet for a single SCS. You may return the frequency arrays in any order. A permutation is a rearrangement of all characters of a string. Each subsequence is a non-empty string that can be derived from another string by deleting some or no characters without changing the order of remaining characters. So, example, the word given is AB, BA. They have given the AB values here 1, 2 and BA values here 2, 1 and continued by zeros. Now, what is the constraints? Word length is lesser than 256 and greater than 1. Words of I dot length is equal to 2 always. All strings in words will altogether be composed of no more than 16 unique lowercase letters. All strings in words are unique. There is no repetitions. Thus, question needs a hint. We'll go for the first hint. Each SCS contains at most two occurrences of each characters. Why? Why? Because length is 2. Max length will be 2 only. It's given here. Now, what is the hint 2? Hint 2 is construct every subset of possible characters 1 or 2. This is our second hint. And the third hint, if a super sequence could be constructed using topological sort, we'll check it. So, this question requires a lot of, what do you say, prerequisites and a very lengthy code actually to solve this question. So, if we go in detail, it's gonna take a lot of time. I'll just explain how this question should be solved. So, first step, the step one, we are gonna pre-process the letters. Well, the purpose is to identify unique letters and else it will be a set containing unique letters from words. Letters sort these unique letters. So next, IND1 will make an will create a map of each letter to its index. Now, ADJ represents adjacency lists for letters used for graph traversal later. LS1 tracks if a letter appears twice in the same word. Example AA. Now, this is the step 1. And if we go to the step 2, in step 2, we have to build a graph. This graph should be like this. For each word, if word length is at least 2 and its first and second letter are mapped to indices A, comma B. And next, add an edge from A to B in the we are making an adjacency list ADJ. In that we have to add a list. Sorry, we have to add an edge from A to B in that adjacency list. Going on to the next one. Mark LS1 of A if the first and the second letters are same. So if first and the second letters are same, for example, A comma A, then we have to mark the letter mark LS1 of A. And next, we'll go to our step 3, which is a very important step. Strongly connected components, SCCs. To find strongly connected components of the graph, we'll use Trajan's Trajan's algorithm for this. So what is Trajan's algorithm? Trajan's algorithm is a graph traversal algorithm. It's basically used to find strongly connected components in a directed graph. What is meaning of strongly connected What is the meaning of strongly connected components? Strongly connected component means it it is a concept in directed graphs actually. Strongly connected components means it's a maximal subgraph where every node is reachable from every other node within the subgraph And also, if you pick any two nodes U and V in SCC, there's a path from U to V and also a path from V to U. For example, if you go from A to B, you can also come back from B to A. There are some properties of SCCs. SCCs are disjoint. A, a single node will belong to only one SCC. And the second thing is, a graph can have multiple SCCs. One single graph will have multiple SCCs. In the case of single SCC, the entire graph is strongly connected. If there is only one SCC, the whole graph will be strongly connected. We'll consider an example: A to B to C to D to A to E to F. Uh, I'll just go for an example. I'll just open Word. Maybe I guess Notepad will be better. We'll open we'll open a Notepad here. We'll consider a directed graph A to B to C to D to A to E to F. I'll just I can't change the colors, so I'll make a small change here. I'll just change this. Okay, let it be. I'll just change this E and F to small e and F. I'll tell you the reason why. In this graph, if I consider this to be a directed graph, A to B to C to D to A to E to F, if I consider this to be a directed graph, these nodes A to B, B to C, C to D, D to A, this is gonna form a SCC, strongly connected component. And also because we can reach to any components here. And also here, if we go to E to F's case, they do form an SCC, but there's no return way. So it does not form. There is no return way from F to E. No F to E. F to E. There's no F to E. So A, B, C, D, A is a SCC here. I guess everyone understood what SCC means. This SCCs will commonly be used in deadlock detection and two-side problem algorithms. And also it's used in analyzing the networks, social networks and communication networks. And also it helps us in understanding the structure of a graph. These are the main steps, or like these are the main users of a SCC. Now we'll come back to our question. Where were we? We were in Tarjan's algorithm. What is Tarjan's algorithm? Anyone in the chat, what is Tarjan's algorithm? Chat, Tarjan's algorithms mean. Anyone in the chat? Tarjan's algorithm is a graph traversal algorithm. It's used to find strongly connected components in a directed graph. The key concepts in Tarjan's algorithm is, I'll again open the notepad. I'll just remove this. Targent's algorithm. Graph traversal algorithm. Why is it used? Used to find SCC. I said what SCC means. What are the key concepts? What are the key concepts here? First one, DFS, DFS traversal. Second one, discovery time. Each node will be assigned with a discovery time when it's first visited. Discovery time. The next thing. What is the another thing? Low link value. Low link value. For each node, low link value represents the smallest discovery time reachable from that node, including itself and its descendants. For example, if it's from A to E, it will include E as well as it will include if your graph is from A to F and low link value of E we are considering, it means that it is gonna consider that time from A to E including E but not F. And next, what is the another very important concept here? It is stack. We are all aware of the data structure stack. Stack is used to keep track of nodes in current path of DFS. So these are the four major important things. How this will work is it will start DFS from unvisited node, then it will assign discovery and low link values, and it will push the node into a stack. And it will update the low link value based on neighbors and back edges. Back edges means if neighbor is already on the stack, then it will consider back edges. When a node's low link value equals the discovery time, it means that the node is the root of an SCC. So when low link time is equal to discovery time, it gives us the root of the SCC, strongly connected component. So then we have to pop the nodes from the stack until the root node is reached. And all these nodes will form one SCC. And we have to repeat this for all nodes. And the time complexity of the Targent's algorithm will be O of V plus E, vertices plus edges, node plus edge. This is about the Targent's algorithm. Sorry. So now we'll come back to the question again. Targent's algorithm will be used here. And after this, what we are gonna do? I said what Targent's algorithm will do. And now in this strongly connected component, step 3 will create results. And that means the nodes in same SCC are grouped together. And and in the next step, step 4, will process each SCC. Will frequency 1 stores letter frequency of arrays of all SCCs. Each link is processed based on its characteristics. And here, each node SCC, if a letter has repetition, it contributes 2 occurrences to SCS. Otherwise, it contributes only one SCC, one occurrence. Multi-node SCC. If it's a multi-node SCC, then no cycles exist within the SCC while forming valid SCS. We'll go to the final step of this question. The final step is we have to combine all the frequencies. We have to collect the frequency arrays for all the SCCs into the final result, and we have to duplicate We have to remove the duplicates caused by the permutations by considering unique frequency arrays. So this is how we are gonna do this question. And here is the code for solving this question. So it's just 362 lines of code. It's here the product and here apply point and define apply function, define the max right, define the minimum left function, define if it is prime function, we are finding the prime number, define the primitive roots, we are defining the primitive roots, and then we are creating the class solution, defining the super sequence. Here we are gonna make all the graphs as well as the arrays, and finally we'll make a function called define solve u, and in that we'll run a for loop again solve 2, and then we'll define the DFS inside this, and then we'll define one more DFS. Finally, we'll return the list of T for T in FST. So we'll run this code if this works for the given test cases. And now we'll submit this question. We'll see if this works for the hidden cases. So this question works. So now this question is a very lengthy as well as a very complicated question which won't be asked in most of the interviews. This question uses multiple algorithms and multiple pre-computations like computing the primitive roots, pre-computing the primitive roots, pre-computing all the prime numbers, minimum left, maximum right, apply points, and all the products, and also all the sets. And here we have made a stack, push, and again init function. So everything. So this is actually a completely competitive coding question, which is not from the interview's perspective. Even if these kinds of questions are asked in the interview, the test cases for them will be very small. So for those cases, you can use another approach. I'll just show you the another approach also which can be used. Just a second. The another approach that can be used to solve these kinds of questions is this method. Here is the question. If this question is asked in interviews also, we can solve it simply with this. We'll create a class solution, we'll create a function, given function, super sequence, and then within that we'll define another function, SCF, which will return string. Then we'll make a DP table, and that will run for range m+1. And this is brute force approach. This is very clearly a brute force approach we are using for DP2D array. And then we'll create get frequencies function, and which will return the frequencies, and then we'll store the input in midway of the function, and also will generate all the pairwise SCS, shortest super sequences, and will next filter out the permutations of each other unique SCS, and then finally we'll convert the super sequences into frequency arrays. So this thing, if we run it, this is gonna clear all the given test cases, and it will also clear some of the hidden test cases also. But this is gonna give an error for us in a edge case, or what we say a super hidden test case. In an edge case, it's gonna give us a rare case or a edge case. This is gonna give us an error. So here we are gonna get an error. So see, in the 598 test case, it's giving us an error. The word is WK, NN, NK, and output should be 0000, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10 zeros, 1, then 2 zeros, after that 2, then 1, 2, 3, 4, 5, 6, 7, 8, 8 zeros and 1, and then 3 zeros. But the output which we are getting here is basically every output here is getting split. So this thing, if this question is asked in the interview, we can simply use this approach of solving using DP2D arrays. It is gonna clear most of the test cases. But if you want the best code, you can actually use the one which we just submitted, the accepted code. This code is gonna this uses a lot of things like lazy segment tree and all the stuff. So which is very complicated, and mostly it won't be asked in any interviews. If they're asking also, the previous code which I showed, which failed in the 598 test case, will be fine. So that's all for today's stream. If anyone has any doubts in any of the four questions or anything about today's contest, you can say it. Any doubts or anything else, any other question, any other doubts you have, you can say it to me. I'll clear it. So if there are no doubts, we are gonna end our stream. So the time complexity of this is the last question is gonna be O of n square if we use just the DP in the failed test case. But in this, if you want to calculate, it is gonna be n power. So we can just ignore time complexity as well as space complexity for these questions, because it's a very huge code. Manually, it's not possible to calculate the time complexity for this. So yeah, that's all for today's stream. Thanks for everyone who joined today's stream. We'll see you in the next stream next Saturday. We'll see you all in the next Saturday. Bye until we meet, guys. Bye bye. Thank you all for joining.